Alright, what's up guys? In this video we're going to start with some differential equations, and we're going to solve another separable equation here. So as to solve this separable ODE, we got dy over dx is equal to e to the x multiplied by y e to the x. So the separable equations are some of the easiest ones that you'll solve. The goal is to separate the variables and integrate both sides. That's the goal. So in this case, we're dealing with the two variables y and x. Just keep in mind that it won't always be y and x. It may be a different variable. It may be x and t. It may not always be y and x, but just keep that in mind. So we want all x's on this side, all y's on that side, or vice versa. All y's on that side, x's on that side, integrate both sides. And that's basically how we solve it. So we're going to get all the y's on the left-hand side. So let's divide both sides of this by y. So we'll get dy over dx. We'll divide this by y, and then we'll have this side over here, which is e to the x times y e to the x. We'll divide that by y, and what that gives us is dy over dx all divided by y is equal to e to the x times e to the x. All right, so now after we divide both sides by y, we'll need to multiply both sides by dx, and multiplying both sides by dx will simply give us dy over y is equal to e to the x times e to the x multiplied by dx. And now the variables are separated. We got all y's on this side, all x's on that side, and we can integrate both sides now. So we're going to integrate dy over y. And we're also going to integrate this side with respect to x. We're going to integrate e to the x times e to the x. We'll integrate that with respect to x. That's kind of how it works. So we know we're going to get ln of y over there, but let's just deal with the integral e to the x times e to the x dx. So that sounds like a hard integral, but it's not at all. It's actually very easy. I can tell the answer is just by looking at it, but let's just go through and work it. So all you really need to do here is a u substitution. Picking u to be e to the x, we know the derivative of e to the x is just itself multiplied by dx, of course. Then we'll have 1 over e to the x du is equal to dx if we actually solve for the dx part. And if you're not sure what happens is, so you have your u, you have e to the u, because you can replace that e to the x with the u. Then you have 1 over u multiplied by du, and what happens is the u's end up canceling out, and we know that the antiderivative of e to the u du is just e to the u plus c, and so all you would have to do is just tackle u back in there, and remember u was e to the x. So if we integrated that right hand side with respect to x, let me get another sheet here. We can go ahead and write our final answer. So if we were integrating, what was it, e to the x times e to the x dx, our answer for this would just be e to the x plus c, or c2, because if we integrated the other side, which was the integral of dy over y, that would just be ln of y plus c1. Again, you don't really need to write c1 and c2 because you combine the constants anyway. So we would essentially end up with ln of y is equal to e to the x plus c. And if we solve this for y, we'll simply just get y is equal to e to the x, and then this will be plus c up here. So our final answer for this separable equation, or when we solve it here, our final answer is y is equal to e to the x, and then there's a plus c up here. So that's your answer for this separable equation. So if you guys got any questions about this, let me know. But like I said, this is a relatively simple example to deal with. All right, so that's going to be it for this one. I will see y'all next time.